Okay, grade 9, good afternoon. Good, good, it's okay. So, students, participation should be uh, very attractive so that we can study more. Students, so we are discussing the topic classification of elements, isn't it? So, in yesterday's class, we discussed about soft shell, orbitals, their types, and other things. And you must know that there are four types of soft shells and four types of orbitals, and they possess different number of electrons. Okay, students, can you see what is shown in the screen? Valence shell and valence electrons. Students, what is discussed inside the class, you must write, you must make a note, then it will be easier one. First of all, let's discuss that an atom has subatomic particles. You know they are protons, neutrons, and electrons. Protons and neutrons, they lie at the center, and electrons lie at the periphery. Then all the atoms do not contain equal number of cells. The number of cells depends upon the number of electrons present in it. First of all, let's discuss one thing. I'm going to circle here one thing, just read it. The outermost shell of an atom is called a valence shell. So, if you see in this atomic structure of calcium, this last shell, this is the valence shell. The shell which lies at the outermost part of an atom is valence shell. And how many electrons are present in that valence shell? That is called valence electron. The number of electrons, the number of electrons present in the valence shell of an atom is called valence electron. There may be one valence electron, two valence electron, 3, 4, 5, 6, 7, maximum 8. But you keep in mind, none of the atom has zero valence electrons. Minimum 1, maximum 8 number of electrons are found there. So, here next definition is given. The electrons, students, is given here. The electrons which lie inner to the valence shell are called core electrons. See, in this chart it is shown that here is given valence electron. So, this is valence electron, and here is valence electron. In these all inner dotted electrons, these are called core electrons. These core electrons cannot move from one place to another. Now, next thing, what is given here? The part of the atom that lies inner to the valence shell is called core of the atom. The part of the atom that lies inner to the valence shell is called core of the atom. The core consists of core electrons, core protons, and neutrons. So I said this outermost one is valence electron, rest of others valence proton, means core proton, core neutron, and core electron. Make your concept clear. Outside one is valence and inside one is core. And we have already discussed about valency. This valency is connected with valence electron. Why? Because this valence electron may go from one atom to another atom, or it may get shared by another atom. There may be transfer of valence electron. There may be sharing of valence electron. Students, look at here. It's given here the cells. 4 cells are given in calcium, and the cells are K, L, M, and N. K cell, L cell, M cell, and N cell. So K cell contains 2 electrons, L cell contains 8 electrons, M cell contains 8 electrons, and N cell contains 2 electrons. Here we have to keep in mind this last 2 means that is valence electron. Here N cell is valence cell, number 2 is valence electrons. So students, what you have to do? You have to remember the core electrons, core protons, valence electrons, and there is no valence proton and valence neutron, because proton and neutron, they lie always at the center. Students, let's see here. It's given electronic configuration of some elements. You can see sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Atomic number we know. Sodium 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18. And you know, sodium has got 3 cells, up to argon 3 cells. Sodium in valence electron is 1, magnesium 2, aluminium 3, silicon 4, phosphorus 5, sulfur 6, chlorine 7, argon 8. Students, now valence electron also again 1, 2, 3, 4, 5, 6, 7, 8. Sodium 1 valence electron, magnesium 2. Why? Because the outermost cell contains 1 electron here, 2 electrons in magnesium, 3 in aluminium, 4 in silicon, 5 phosphorus, 6 sulfur, 7 chlorine, 8 argon. Now students, what is next? Valency. Valency means, what is the definition of valency? Valency is defined as the number of electrons shared or donated or received. Valency of sodium is 1, magnesium 2, aluminium 3, silicon 4, phosphorus 3, sulfur 2, chlorine 1, argon 0. Why argon 0? Because if there are 8 electrons, then it is stable. It neither gains electrons nor receives electrons nor shares. Okay, look at here. It's given if number of electrons or valence electrons is 1 to 4, valency is 1 to 4. But if number of valence electrons is 5 to 8, then valency will be 3, 2, 1, 0. Just opposite. Look at here. Here is 1, 2, 3, 4 going up, and 3, 2, 1, 0. Here is 1, here is 2, here is 3, here is 4, right? Then here is 3, 2, 1, 0. See, 1, 2, 3, 4, increasing, 3, 2, 1, 0. So that things you have to keep in mind. So students, generally active elements, they have valency 1, and passive elements, they don't have valency. Valency is 0. So this chart shows the number of valence electrons and number of core electrons. So core electrons, they lie inner to valence shell. Now let's discuss next thing. Here is given one atomic structure. Which atomic structure is given? Potassium. Potassium, students, you just check it here. This one, this is valence electron, and these all inner one, whatever is there, that is core electron, core proton, core neutron. In potassium, there are 4 cells. Cell K, L, M, N. K, L, M, N. K contains 2 electrons, L contains 8, N contains 8, and N contains 1. So this is became mistake. So electronic configuration is K, L, M, N. But according to orbital, it is like this here. What is given? I'll show you here. 2881. That is not 2. 1. That is according to cell. But according to soft cell or orbital, it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. How is it done? I'll just guide you like this here. Students, it is given 1s2, means see here. First, 2 electrons. 2s2, 2p6, that is second 8 electrons. 3s2, 3p6, that is third 8 electrons. And 4s1, it is not 2. This is not 2, this must be 1. 4s1. And valence cell is here fourth. Valence electron is 1. And this whatever is here in this box, let me show you. Whatever is there in this whole box, they are core electrons, core protons, core neutrons. So outermost is valence and rest of other is core. So students, here we can say 18 core electrons, 19 protons and 20 neutrons and 1 valence electron. Where in case of potassium, My dear students, now let's discuss next thing. Information from valence electrons. What information we get it? Valence electrons of an atom gives us information about the combining capacity or valency of the element. By observing valence electrons, by studying valence electrons, we can say about the valency. Number second, the number of valence electrons of an atom gives us an idea about the group of the periodic table in which the element falls. Students, there are altogether 18 groups. So, by observing valence electrons, we can find out whether the element lies in first group, second group, third group, fourth group, fifth group, etc. Okay? So, basically, it is applicable for group 1A to group 8 elements. 1A to 8, about that we have to discuss in class 10. Now, third point is there. The number of cells determines the period to which the element falls in the periodic table. So, students, just let's take one example. So, here it is given. Students, just you let me circle it. Here is given 4s1. 4s1 means its valency is 1. It falls in which group? 1 group, 1A group. Okay. And here is number 4. It means it lies in fourth period. In which period? Fourth period. Group 1A, fourth period. By looking the valence shell, valence electron, we can say group, period, valency, etc. So is it important or not? Definitely it is important. My dear students, I hope you are writing. Please write down. It will be quite easy for you. Now here is given one heading. What is the next heading? Valency. Just before we said that, according to the number of valence electrons, we can find its combining capacity. So that combining capacity of an element or the radical with the other element or radical to form a molecule or compound is called valency. This, what to do? You have to underline it. You have to mark it. The combining capacity of an element or radical with other element or radical to form a molecule or a compound is valency. And for valency, we use the numbers 1, 2, 3, 4, 5, 6. It means the valency of an element may be from 1 to 6. 1 to 6 means either one electron is shared or donated or received. So valency tells us how many electrons are gained or shared or received. Okay, students. Now let's discuss the next heading, ways of finding out valencies. It will be discussed after some time. Let me see what are the students of class 9 doing now. Let's check. So, okay, everybody, please unmute your audio. Did you unmute your audio? Neha, Sunayana, Samiksha, unmute it, please. So that when I say you to say something, then you can do. Samiksha, you can unmute. Now this is the time to speak, okay? First of all, Neha. Neha, what did you write? Will you read? It's Neha's turn. Neha, you read now. Why she is not reading? You can read. Okay, Sunayana, can you read? What happened, Sunayana?
Yes, sir.
Okay, please. What did you write? Please read. You didn't write anything.
Valence,
Okay, please.
sir.
Yeah, you okay? Please read.
Valence electrons, their definition,
Okay,
and then the core electrons,
good.
then the importance of valence electrons,
Okay,
then the valency,
all right.
definition of the case.
All right. And where is Samiksha? Samiksha is there?
Yes, sir.
Please write some definitions or something. What you did? Come on, you say.
I also wrote definition of valence electrons.
Okay,
core
okay.
Electrons
We will.
and
Will you define valence electron?
valence electrons, sir.
Yeah.
The electrons present in the valence shell of one atom of an element are called valence electrons.
Good. And valency?
Sorry, sir.
Define valency.
The combining capacity
That's good. And Valency ranges from which number? 1 to 6, 1 to 8, 1 to 10. Valency ranges from 1 to 6. Okay, 1 to 6. Yeah, minimum valency is 1, maximum it goes up to 6. Okay, students, now we are going to discuss next thing. What is here? Let me share once. What am I sharing? Sharing thing is here. Probably that may be the last portion for today. I'm going to check now. So this is the time to share the screen. Okay, what is the heading now? Ways of finding out the valencies. So to find the valency of element, radical, or any others, so we will take the valency of hydrogen, oxygen, and chlorine as standard radical, because the valency of hydrogen is 1, valency of oxygen is 2, valency of chlorine is 1, and most of the compounds contain hydrogen, oxygen, or chlorine. That's why we have to remember the valency of hydrogen 1, chlorine 1, oxygen 2. Students, look at here. The valency of chlorine in hydrochloric acid HCl is 1. Why? Because the valency of hydrogen is 1. The valency of oxygen O in water H2O is 2, because one atom of O combines with two atom of hydrogen. Here we are just discussing, eh? Like if there is NH3. NH3 means valency of hydrogen is 1, we know. But in hydrogen side there is 3, means valency of nitrogen is 3. The valency of carbon in methane CH4 is 4, because in H side there is 4. So the valency of nitrate in nitric acid is 1, because the hydrogen atoms radical means valency is 1. Students, here is given something. So let's see here. What is the thing? Is, let me underline once and explain. The valency of an element may be defined as the number of hydrogen atoms which can combine to one atom of the element or one molecule of radical. So, how many hydrogen atoms can react with that particular atom or radical? That is the valency. Okay, so here is given the valency of elements or the radicals can be determined with the help of chlorine also. Why? Because we know the valency of chlorine is also 1, hydrogen also 1. So let's see point wise what is given here. First point, there is NaCl, sodium chloride. We know the valency of chlorine is 1, and there is NaCl 1 1 means valency is 1. But in MgCl2, there are 2 chlorines needed for magnesium, means valency of magnesium is 2. Third point, AlCl3, valency is 3 of aluminum, because there is Cl3. And in CaO, calcium oxide, we know valency of oxygen is 2, and valency of calcium also becomes how much? 2. It must be equal, not 1. Students, it is given here one thing. One example, find the valency of phosphorus in P2O5. Students, very simple. We know the valency of oxygen is 2. In P there is 2. It means in O there is 5. Just we have to see opposite side. So the valency of P is 5 while valency of O is 2. Just look in each other's side. What is the number? That is the valency. For example, if I write if I write K K2O potassium oxide K2O. In this case, look at here. The valency of oxygen is 2. This side K2O. Just check it here. The valency of oxygen is 2, but valency of potassium is 1. There is nothing means 1. So valency of potassium 1, valency of oxygen 2. So if you see just each other side, you will find the valency of elements. Okay, students, let's go to next page. What does it say? I'm going to explain now. Okay, number B. What is given here? The number of valence electrons present in the valence shell of an atom of an element determines the valency of that element. Already we discussed how many electrons are present in last orbit, that is the valency. Accordingly, we can denote. But one thing remember, if outermost side contains 1 electron, 2 electron, 3 electron, 4 electron, that is valency 1, 2, 3, 4. But if 5 electrons are present, then valency will be 3. Why? We have to make 8. Okay, 5 plus 3 is 8. If there are 6 electrons in outermost side, valency will be 2. If 7, valency 1. If 8, valency 0. Already I just said. Number C, the number of electrons lost or gained or contributed for sharing by an atom in the formation of a chemical bond or during molecule formation determines the valency. Valency can be calculated by in this way also. How many electrons are lost, gained, or shared? And inert gases, their outermost orbit is full of electrons, their valency is 0. They do not take part in chemical reaction. Students, is given here variable valency. Here we have to keep in mind most of the elements they have got only one valency, but some elements they have got two valencies. If those elements have got two valencies, that is called variable valency. Elements, some elements contain more than one valency, they are called, or that is called variable valency. Example, look at your table. Nitrogen has got two valencies, 3 and 5. Phosphorus, 3 and 5. Manganese, 2 and 4. Iron, 2 and 3. Silver, 1 and 3. Copper, 1 and 2. Lead, 2 and 4. Tin, 2 and 4. Gold, 1 and 3. These are electron donors. Okay, so if the valence is less, their suffix is OUS, and if their valence is high, their suffix is IC. Like we can say here, copper. For example, copper valency 1 means Q plus, valency 2 means Q prick. Lead valency 2 plumbus, valency 4 plumbic. Tin stannous, stannic. Gold aurum or aurus, auric. So these elements which valency is variable gain or lose not a fixed number of electrons, sometimes more, sometimes less. So students, that is all about today's matter. So today we discussed valency and how to determine the valency, valence cell, valence electron, isn't it? And note is already sent to you. Please make fair, and I will give you the questions next day. With I think when the chapter is over, some questions will be given to you. You have to complete. Are you ready? Yes or no? So read and make attractive notes. So before starting our next lesson, you must be able to explain it. So you have to be smart and do well. Okay, students? Is that okay?
Okay, sir.
Okay. So please make attractive note and present tomorrow. So you are the genius students of Anupam, and you can do much better. So today this much. Have a nice time and bye bye.